Hey guys, today we're going to have a look at arc lengths. And as we've been working with circle formulas recently, arc length should be a breeze. Now just a heads up, anytime you see a curved shape, for the time being, we're going to assume that it's going to be a part of a circle. In future, it'll be a bit more complicated than that, but for now we can make that assumption. So when we're talking about arc lengths, like a semicircle, for example, that's a fraction of a circle. Now, how do we know that it's half a circle? Well, we could show that by marking the center of where the circle would be and drawing the radius from that center out to either end of the arc. And with the case of a semicircle, we've drawn a straight line. That is, those two radiuses have a 180 degree between them. And 180 degrees is half of a full turn. So we could say that the length of a semicircular arc is the fraction 180 over 360 of the full circumference, or simply a half of 2 pi r. Remember our formula for the circumference of a full circle was 2 pi r? Well, this is half of it. Now for any arc length, we should be thinking that this is a fraction of the circumference of the circle. To work out which fraction it is, again, mark where the center of the circle would be and draw your radiuses, or radii, out from the center to the ends of the arc. Then work out the angle that forms between those two radii. The arc length will be equal to that fraction of the full circumference. So that angle over 360 multiplied by 2 pi r. Let's do an example here. Work out the arc length of this arc. I've got radiuses, or radii, of 18 centimeters, and I've got an angle between them of 120 degrees. So setting out my formula, arc length is equal to some fraction of 2 pi r. That fraction is going to be 120 over 360. And my radius is 18, so I've substituted that in. Now, it might help if you simplify this before you start working this through. 120 over 360 is the same thing as 1/3, and 2 times 18 is 36. Now, multiplying a fraction by a whole number, term, or value, we only need to multiply the top of the fraction. So I'm going to do 36 pi times by the 1 and leaving that on the 3 at the bottom. Now 36 pi can be divided by 3. 36 divided by 3 is 12. So this is going to be 12 pi centimeters. Now that is an exact answer in terms of pi. Remember, we've been working on that. But if you work that through to 3 significant figures, that would be 37.7 centimeters. Notice the symbol there, it's not exact, it's been rounded. Example 2. Now work out the radius. I'm giving you the arc length, and I'm giving you the exact arc length in terms of pi. Work out the radius by using the formula. Remember, our formula is that this is some fraction of the full circle. So the arc length is equal to the angle over 360 times 2 pi r. Now I know the angle, it's 60 degrees, and I know the arc length is 18 pi. So I've substituted those into the formula. But the one thing I don't know yet is what the radius is. So I'm going to need to simplify this equation and get the r on its own to solve. 60 divided by 360, that can be simplified. That's 1/6. Now to simplify that, remember multiplying a fraction by a whole number. We just need to multiply the top. So I did 2 pi r times the 1, and I left that over 6. And now to get r on its own, I see that it's being multiplied by 2 pi and divided by 6. So I'll take my 6 across and I'll multiply, and then I'll take my 2 pi across and divide. So 108 pi divided by 2 pi, I can see that's going to simplify nicely. Pi divided by pi will cancel out, and 108 divided by 2 is 54 centimeters. So I have an exact answer for r. I didn't need to round it at all. r is 54 centimeters. Here's another example. Work out the perimeter of this sector. Now keep in mind the perimeter includes all of the outer edges. So that's the arc and the radiuses. The perimeter is equal to the arc plus 2r, 2 of the radiuses. The arc is a fraction of 2 pi r, and my 2 radiuses, of course, 2r. I know the angle, and I know the radius, so I substituted those in. I put 72 in for this angle, theta, and I've put 23 in for the value of r. So instead of 2 pi r, I've got 2 pi 23, And instead of add 2r, I've got add 2 23s. Simplifying that, 2 times 23 was 46, and 2 times 23 was 46. So I've got 46 pi, and I've got 46. And the 72 over 360, that simplified to 1/5, dividing both top and bottom by 72. Again, multiplying by a fraction, we only need to multiply the top of the fraction. So that's going to be 46 pi times by the 1, leaving it over 5. And that is my exact answer. I can't really take it any further, except maybe to multiply 46 by 5 and then put it over 5 and group it together. But really, I can't get that any simpler. So that's my answer in centimeters, or I can work it out to 3 significant figures. This is rounded, not exact, 74.9 centimeters. Example 4, now I'm giving you the radiuses, and I'm giving you the perimeter, but I'm not giving you the angle. Let's work out the angle the same way. Set out the formula, substitute your values in, and rearrange to find what you don't know. So our formula, the perimeter is equal to the arc plus 2 radiuses. I know the arc is a fraction of the circumference of the circle. And I know the radiuses I can substitute in, and I know the perimeter was pi plus 30. So rearranging this, I can simplify first. 2 pi times 15, that's 2 times 15 is 30, plus 2 times 15 is 30. And this is just multiplying by the top of the fraction. So I've got 30 pi times by the angle theta, which I'm just labeling as that Greek letter theta for now until I figure out what it is. Now simplifying this, I can obviously move the 30 to the other side. It was plus, now it's minus. And simplifying this fraction, I can see that I divide both the top and the bottom by both 30. This simplifies out nicely. That's going to become 0. So pi plus 0. Now I've taken my denominator across. It was dividing, so now I've multiplied. So I've got pi times 12 is equal to pi theta. And I want theta on its own. I know that's going to be 12 pi, but I need to get rid of this pi from this side. So I'll take it to the other side and divide by it. And that will simplify out really nicely. 12 times pi divided by pi is just 12. So my angle is just 12 degrees. Last example, and it's a hard one, notice the star. Work out the radius, given that the perimeter of the sector is 20 centimeters. Okay, so that's the full perimeter. That's the arc length plus the 2 radiuses. I know that the arc length is going to be a fraction of the circumference, where the angle at the center is 54. So that's going to be 54 over 360 times by the circumference. And I know that the perimeter was given is 20. So I put that value in for the perimeter so that I've got an equation that I can rearrange and solve. Let's simplify this first. First I did 2 pi r multiplied by the top of the fraction only. That's going to give me 108 pi r, because 2 times 54, over 360. Plus my 2r. That was not getting multiplied by the fraction. That is a separate term. And that all equals to 20. Now we want to find out what r is. We're going to need to simplify this a bit more and try and get our r's together and then get r on its own. Now this is the tricky bit. First I've simplified my fraction. I can divide both the top and the bottom of that fraction by 36. And now I want to group my r's. So I turn this whole number into a fraction by multiplying it by 10 and then putting that value over 10. So you see I have a common denominator here. Now I can group these two terms together, put them both as a fraction over 10. So that's 3 pi r plus 20r over 10. I want to get the r on its own, so I'm going to try and get rid of this fraction here. This is all getting divided by 10. So now I can take the 10 to the other side and multiply. Looking a little bit simpler, I don't have a fraction anymore. Working that through, that's 200. This here, however, I need to somehow get my r's together. Notice that this is some number of r and that's some number of r. Together, these are two terms that are being multiplied by r. So I can factor the r out. That is, I can divide both of those terms by r and put the r outside a bracket. You see how this is the same as the step above? If I were to multiply this through, this would be 3 pi r plus 20r. So it's the same as what I have here. There, I've just multiplied my 20 by my 10, so that's 200. And although this looks complicated, we are one step away from our answer. R is being multiplied by all of this. So to get the R on its own, let's move this to the other side and divide. And there we have it. R is on its own, and that is its exact answer. Now, it may not look pretty to you, but it's exact. If you want to get that answer to 3 significant figures, go ahead and plug it into your calculator, but I'm just going to leave it like that. Let's get on to some practice, and I promise I won't give you anything as difficult as this, but I think it was worthwhile to see. Now here I've given you some radiuses, some angles, some arc lengths, and some perimeters of this sector. I only gave you one perimeter of this sector because that's the hardest one. Okay, given the radius and the angle, work out the length of the arc. And to find a perimeter, just don't forget, we just need to add on 2 radiuses to that. Okay, given the arc and the radius, work backwards to find the angle. And remember, the perimeter is just the arc length plus 2 radiuses. Okay, so I'll leave you with that here. Go ahead and hit pause so you have time to do it. Don't just fill in the table. Set out your working. Set out the formula for the length of an arc and rearrange to find the missing values. Once you've got the arc length, and if you know the radius lengths, you can easily work out the perimeter. Now I hope you've had a chance to hit pause because here come your answers. Have a look over those answers carefully. If you've worked your answers out to 3 significant figures, that is, you've calculated this, you're going to need to put this into your calculator and see if you've got the same answer as I've got here as an exact answer. Please have a look over those. Let me know if you have any problems. Otherwise, that's all for today.